The purpose of this demonstration is to show the empirical rule, or the 68, 95, 99.7 rule graphically. Now, what I have set up here is I've set up a standard normal with a mean of 0 and a standard deviation of 1, and I've gone on ahead and clicked the two tails to show how this works. Now, when I click on one of these flags, and when I bring them together, I'm getting approximately the entire area under the curve shaded, and that's about 1. Now when I move this out, move one of these flags out to 1 standard deviation, we see that we have about 16% shaded on each side. Now on each side, because of the symmetry of the curve, these regions are equal in area. So we have about 16% on each side shaded. That's about 32% total. And that implies that the unshaded region right here has an area of about 68%. And that is where the 68 part of the rule comes from. When you grab one of these flags and go further out to 2 standard deviations on either side, you have about a little less than 2.5% on each side. Now when you add those together, you get a little bit more than 4%, and that means that the unshaded region here has around 95%, and that's where the 95 part of the rule comes from. So right now we have 68 and 95, and then you have 99.7, and again that's because 3 standard deviations out you have about 0.14% of the area shaded on each side, and when you combine those, that's about 0.28. So that means that this unshaded portion under the curve is about 99.7, and that's where that third part of the rule comes from. And this is what the empirical rule is telling us from a graphical standpoint, is that if I move out a certain integer value of standard deviations, I can get a certain amount of area under the normal curve. And this is true for any normal curve. If we change the standard deviation to 3, we see that the scaling has changed down here, but the percentages of the areas have not. And this is a very, very nice property of normal densities, is that when you change the standard deviation, or the mean for that matter, you do not change the amount of area under the curve for these standard deviations as the empirical rule suggests. They stay the same. And this is how the empirical rule looks when applied to a normal density.